Good morning, students. Welcome to today's lecture. So, in our last lecture, we had seen uh, the different types of fluid flow. Okay, I think we had seen in past lectures. Then we had seen the discharge. We had solved the problems on discharge. Then we had seen continuity equation for one-dimensional fluid flow. That is mass flow rate in equals to mass flow rate out. That means rho one A1 V1. That equals to rho two A2 V2. Okay. After that, in yesterday's lecture, we had seen the continuity equation for three-dimensional fluid flow, and we had derived the equation for incompressible steady fluid flow. So it is given by del U by del X plus del V by del Y plus del W by del Z equals to 0. Okay. For two-dimensional fluid flow, W equals to 0. Therefore, it can be reduced to del U by del X plus del V by del Y, that equals to 0. Okay. After that, we had seen the two important property, that is velocity and acceleration. So velocity is nothing but is a rate of change of displacement with respect to time, and velocity is a function of space and time. Therefore, if u and w are the components, so u and w, they are the function of x, y, z, and t. Okay. After that, we had seen the acceleration. So acceleration is nothing but the rate of change of velocity with respect to time. Okay. So if ax, ay, and az, these are the total acceleration in x, y, and z direction, then ax equals to del u by u del u by del x plus v del u by del y plus w del u by del z plus del u by del t. Okay. This we had derived in our last lecture. Okay. After remember, here this term u del u by del x, v del u by del y, w del u by del z, this u del v by del x, okay, all these 9 terms, they represents the rate of change of velocity with respect to direction. So they are called as convective acceleration. And this term del u by del t, this represents rate of change of velocity with respect to time, and hence it is called as local acceleration. Therefore, in general, total acceleration equals to convective acceleration plus local acceleration. Okay. For steady flow, okay, the rate of change of velocity with respect to time is 0. Del u by del t is 0. Therefore, local acceleration is 0. Therefore, total acceleration is equal to convective acceleration. Then, for uniform flow, so uniform flow may rate of change of velocity with respect to direction will be 0. So these all 9 terms will be 0. Okay. Therefore, total acceleration equals to local acceleration. And for steady uniform flow, both local and convective acceleration is 0. Therefore, total acceleration equals to 0. Okay. After that, we had seen the numericals on one numerical on velocity and acceleration, one numerical on continuity equation. Okay. And I think third numerical also we had seen. Okay, that is also on continuity equation. Okay. After that, in our last lecture, we had seen what are the different types of motion of fluid particles that are possible. Okay. So during the course of movement, in the direction of flow, the fluid particle may have the combination of one or more of these motions. Okay. So they are linear translation, linear deformation, angular deformation, and rotation. So if fluid particle moves from one point to other point such that in new position, the median lines are parallel to that in old position and are equal in length. Okay. So that type of motion is called as pure translation. And second is linear deformation. So in linear deformation, the median lines during the movement of fluid particle, the median lines remain parallel to old position. Okay. But their length changes. Okay. Then in angular deformation, the fluid particle or the medians of fluid particle rotate by equal amount but in opposite direction. Okay. Then in rotation, the two median lines of a fluid particle rotate by equal amount in same direction. So I think all this we had seen. And out of all these 4, basically we are going to focus on the 4 type of rotation, motion, that is rotation. So we had seen angular velocity. Angular velocity is nothing but rate of change of angular displacement per unit time. It is denoted by omega. So omega equals to dt by dt. After that, component of rotation. So component of rotation about any axis is nothing but it is the average of the angular velocities of two infinitely linear elements which are perpendicular to each other and also perpendicular to axis of rotation. Okay. So इसका हमने definition कल डिटेल में देखा था. उसके बाद में मैंने आपको एक shortcut trick बताया था to remember the formula. Okay. And what was that shortcut trick? Okay. quickly we will revise. So after x comes y, after y comes z, and after z comes x. Okay, then component of velocity in x direction is u, in y direction is v, in z direction it is w. Okay, से फॉर्मूला याद रखने के लिए आपको जनरल उसका जो स्ट्रक्चर है वो याद रखना है, दैट इज ओमेगा इक्वल्स टू 1/2 डेल बाय डेल माइनस डेल बाय डेल. ओके, सो अभी यहाँ पे हमको ओमेगा जेड निकालना है, तो जेड के बाद क्या आता है एक्स, सो दिस इज ओमेगा जेड, ओमेगा जेड 1/2, यहाँ पे डेल में जेड के बाद एक्स आता है, सो हियर एक्स आफ्टर एक्स कम्स वाई. ओके, देन यहाँ पे जेड का कंपोनेंट डब्ल्यू छोड़ देना है, कट कर देना है, सो सिर्फ दो कंपोनेंट बचे यू एंड वी. ओके, तो वी का यू का कंपोनेंट वाई का कंपोनेंट एक्स के साथ लेना है, मतलब वी, और एक्स का कंपोनेंट वाई के साथ लेना है, दैट मींस यू. Similarly, here omega x. Okay, so omega x is 1/2 del by del minus del by del. Okay, again here after x come y, after y comes z, then z का component is w, which will be taken with y का component v, which will be taken with z. Okay, so del w by del y minus del v by del z, del v by del z. Okay, similarly omega y, so equals to 1/2 again del by del minus del by del. Okay, remember here after y comes z and after z comes x. Okay, x का component u z के साथ लेंगे, z का component w x के साथ लेंगे. Okay, so in this way with this shortcut trick you can remember the formula. Okay, then for rotational flow, irrotational flow, basically there is no rotation which is taking place, therefore component of rotations are 0. Then what is it is simply defined as 2 times or twice the component of rotation. Okay, so I think हम इसके numerical start करने वाले थे. So write down first numerical. A fluid flow is given by vector v equals to 8x cube I minus 10x square yz. Vector v equals to 8x cube I minus 10x square yj. X square yj. Find the shear strength. Find the shear strain rate and state whether the flow is rotational or irrotational. Okay, so we are supposed to find out the shear strain rate. Okay, and we are also supposed to find out whether the flow is rotational or irrotational. So first of all, vector v is given by 8x cube I minus 10x square y j cap. Okay, so from this we can say u equals to 8x cube and v equals to minus 10x square y. Okay, therefore u equals to 8x cube, so del u by del x. Okay, so 8 as it is constant रहेगा, x cube का differentiation क्या होता है 3x square. Okay, so 3 8s are 24, so it is 25x square. Okay, similarly हम del u by del y भी निकाल लेंगे, so del u by del y, y से differentiate करेंगे तो there is no term of y, so it will be 0. Similarly v equals to minus 10x square y. Okay, therefore del v by del x, यहाँ पे x से differentiate करेंगे, so minus 10y constant रहेगा, x square का differentiation 2x, so minus 10y into 2x, that is minus 20xy. Similarly del v by del y, so y से differentiate करेंगे, so minus 10x square common and the differentiation of y is 1, so it is minus 10x square. Okay, so हमने चारों टर्म निकाली, del u by del x, del u by del y, del v by del x, del v by del y. Okay, now first of all rate of shear strain, so we know rate of shear strain is given by 1/2. Okay, del v by del x plus del u by del y. Okay, so it is 1/2 del v by del x plus del u by del y. So put the values, so it is 1/2 del v by del x कितना minus 20x plus del u by del y is 0. Okay, that equals to minus 20x by 2, so it is minus 10xy. Okay, then second is check whether द फ्लो इज रोटेशनल और इरोटेशनल। अभी एक्चुअली आपको फ्लो में है ना जेड डायरेक्शन नहीं दी है, ओके। तो बेसिकली जेड क्या हो जाएंगी, एक्सिस हो जाएंगी, ओके। मतलब प्लेन कहाँ पे है, हमारे पार्टिकल फ्लो कहाँ हो रहा है, एक्स और वाई डायरेक्शन में फ्लूइड पार्टिकल का लोकेशन है, तो उसका रोटेशन जेड एक्सिस में रहेगा, ओके। सो फॉर दिस वी आर सपोज टू चेक ओमेगा जेड, ओके। यहाँ पे जेड का कॉम्पोनेंट नहीं है, सो बेसिकली हम चेक क्या करेंगे अबाउट जेड एक्सिस। So we know omega z is given by omega z equals to 1 by 2 del v by del x minus del u by del y। अब ये फॉर्मूला कैसे याद रखना उसका ट्रिक अभी हमने डिस्कस किया है, ओके। सो यहाँ पे पुट कर दो वैल्यू, सो इट इज 1 by 2 del v by del x कितना है, del v by del x is minus 20xy and del u by del y is 0, okay। So again put, so 1 by 2 into minus 20xy, so finally on cancellation we will have minus 10xy, ओके। एंड दैट इज नॉट इक्वल्स टू जीरो। ये कभी इक्वल्स टू जीरो आता था तो फ्लो इरोटेशनल रहता था, बट दैट इज नॉट इक्वल्स टू जीरो, देयरफॉर फ्लो इज रोटेशनल फ्लो, ओके। ये जीरो नहीं आया है इसलिए फ्लो कौन सा रहेगा, रोटेशनल फ्लो। इफ इट इज इक्वल टू जीरो then the flow will be irrotational flow, okay? Similarly we will see next problem, the velocity component in a two-dimensional flow rate are u equals to y cube by 3 plus 2x minus x square y, okay, this is the value of u, and v equals to xy square minus 2y minus x cube by 3, okay. Show that this component represents a possible case of irrotational flow, okay. So we are supposed to check whether the flow is rotational or irrotational flow. So first of all we will calculate u, del u by del x and del u by del y, okay. So u is given by y cube by 3 plus 2x minus 10x square y, so del u by del x से differentiate करेंगे, so first term x नहीं है, so its differentiation will be 0, then here 2x का differentiation 2, then here y will be constant and x square का differentiation 2x, so it will be minus 2xy, okay. Similarly del u by del y, del u by del y y से डिफरेंशिएट करेंगे, सो y क्यूब का डिफरेंशिएशन होता है 3y स्क्वायर, तो 3y स्क्वायर डिवाइडेड बाय 3, यहाँ पे x का टर्म नहीं है, y का टर्म नहीं है, सो इसका डिफरेंशिएशन 0 होगा, एंड हियर डिफरेंशिएशन ऑफ माइनस x स्क्वायर y विल बी माइनस x स्क्वायर, ओके। सो 3 कैंसल, सो फाइनली वी विल हैव y स्क्वायर माइनस x स्क्वायर, ओके। Similarly v is given by xy square minus 2y minus x cube by 3, okay. Therefore we will calculate del v by del x and del v by del y, so del v by del y, so del v by del y से डिफरेंशिएट करो तो y स्क्वायर का 2y होगा मल्टीप्लाई बाय x, सो 2xy, यहाँ पे 2y का 2 माइनस 2 होगा, और यहाँ पे y का टर्म एब्सेंट है, सो डिफरेंशिएशन विल बी 0, ओके। सिमिलरली del v by del x, सो x से डिफरेंशिएट करेंगे तो यहाँ पे x का डिफरेंशिएशन 1 हुआ, y स्क्वायर कांस्टेंट है, सो y स्क्वायर, यहाँ पे 2 इंटू देयर इज नो टर्म ऑफ x, सो इट इज 0, और यहाँ पे x क्यूब का होगा 3x स्क्वायर बाय 3, तो 3 कैंसल, फाइनली y स्क्वायर माइनस x स्क्वायर, ओके। नाउ पहले हमें चेक करना है वेदर इट इज अ पॉसिबल केस ऑफ फ्लो, और कभी पॉसिबल केस ऑफ फ्लो है, ओके, तो हमें प्रूव करना है कि इट इज रोटेशनल, हमें शो दैट करना है। सो बेसिकली ये प्रॉब्लम में हमें दो चीज प्रूव करनी है, पहले तो पॉसिबल केस ऑफ फ्लो है, ओके, ये प्रूव करना है, और पॉसिबल केस ऑफ फ्लो होने के बाद इरोटेशनल है, ये प्रूव करना है। सो फर्स्ट ऑफ ऑल पॉसिबल केस ऑफ फ्लो के लिए क्या सेटिस्फाई होना चाहिए, कॉन्टिन्यूटी इक्वेशन। So for two-dimensional flow, the possible case of flow is continuity equation, which is del u by del x plus del v by del y, that equals to should be equals to 0. So del u by del x का value put कर दो, it is 2 minus 2xy plus del v by del y का value put कर दो plus 2xy minus 2. Okay, so it will be del u by del x plus del v by del y, that equals to 2 minus 2xy, 2 minus 2xy plus 2xy minus 2 plus 2xy minus 2. So 2 minus 2 cancel, minus 2xy plus 2xy cancel, that equals to 0. Therefore the given problem or the given case is a possible case of fluid flow, okay. अब इसके बाद हमें प्रूव करना है इट इज अ इरोटेशनल फ्लो। तो इरोटेशनल फ्लो के लिए बेसिकली यहाँ पे W नहीं दिया है, तो बेसिकली रोटेशन विल बी टेकिंग प्लेस अलोंग z एक्सिस, हमें ओमेगा z इक्वल्स टू 0 पुट करना है, प्रूव करना है, ओके। So axis component of rotation omega z is given by omega z equals to 1 by 2 del v by del x minus del u by del y. Okay, so we'll put the value of del v by del x and del u by del y. So it is y square minus x square and y square minus x square. 1 by 2 y square minus x square minus of y square minus x square. So on opening this, so ये cancel हो जाएंगे. Okay, so it will be finally 0. Therefore, as component of rotation is 0, it means the given flow is irrotational flow. Okay, hence we can prove that the above component of velocity u and v represents a possible case of irrotational flow.